I'm happy to be with you today and to present this lecture. It will be about architecting intelligence, how we can explore together the AI workflows which are shaping the next design generation. You can see the slide, right? Okay, great. In this lecture, I will try to differentiate with some concepts like parametric, algorithmic, and generative design through our experimentation at Getinform School. And we will see how we can translate natural language inputs and feed them into tools like Grasshopper, transforming them into either parametric or generative models. The main aim is to shape new design generation workflow. AI, here that we can use the artificial intelligence as to increase the creativity and persistence, and also to reduce the time of the design process. I think the video is not working, right? Okay, it's fine. So currently, when most people hear about artificial intelligence in architecture, their minds immediately turn to ChatGPT, large language models, Midjourney, diffusion models. However, we can use it more beyond this. Like we can use it deeper than these tools, and we'll see how AI could help us in the design process. Now we are engaging in a comprehensive dialogue with a machine that can learn and understand, analyze, and provide highly informed answers. Therefore, our task is to discover the maximum potential of artificial intelligence to truly assist and elevate our design process. It's important to understand that artificial intelligence is not set to replace our creativity, as it's said, but it will change how we perceive things and how we translate information into code or into code that will help in building the architecture that will exist on the ground. So, do we begin this integration? We must teach the machine how to comprehend and how to understand what we are working on, like geometry, proportion, daylighting, and logic. Then it translates into data and understand complex relationships and then perform interactions. It must be capable of deduction and problem solving while replacing the existing constraints. So we are moving away from simply drawing faster. Instead, we are building systems that can grow and evolve based on our design intent. Let's see what is the foundation origin of AI. It is the algorithm. An algorithm has existed for a long time, dating back from the ancient civilizations. For example, the construction of the pyramid, the construction of the pyramid, which are built on proportions and mathematics that interpret the cosmic orbits in geometry. And the same we can see in the Greek civilization as well, when they used golden ratio in the building, like in the Parthenon. So architecture was coded by the need and the nature and the proportion. We translate the needs, design guidelines, context, and architecture proportions into a code, a set of rules that guides constructions. This original methodology is a form of a human algorithm. It's a set of rules, again, used to achieve a desired outcome, incorporating factors like heat, light, gravity, and social needs, which are all translated into rules and patterns. Therefore, AI is not replacing human logic. It will help us more to discover what the human logic is. The word algorithm itself derives from Al-Khwarizmi, who is considered the father of the algorithm, because he was the first to formalize steps for solving inheritance equations, as well as determining the angle of Qibla toward Mecca. That was basically considered the origin of the computation and the AI we see today. Next, there is an important source of algorithmic design was Christopher Alexander. His book, The Pattern Language, translated natural life pattern into mathematics and algorithms. He described the network of decisions where every door, every window, every tree or every corner, every street, everything that has to follow a specific rule, leading to the realization that life is a large system of relationship. Each pattern was like a small piece of code capturing both logic and feeling. We can simply say that recipe is a kind of steps that could achieve the recipe at the end. So algorithm is a set of rules that we follow. This brings us to parametric design. Parametric design is different from algorithmic design, and it means that establishing relationship between parts based on defined set of rules or algorithms. Like Alexander says in his pattern language book, it's about building a system and defining part-to-part systems, and also the relationship between the part to the whole systems. Every component acts as a part of a larger system reacting to any change. If one part changes, the entire system responds based on that change. The algorithm is written in different ways. We can write it like natural language, and we can write it also like a pseudocode. Pseudocode is a kind of natural language but with coding, but follows some rules using commands like if and then, for each panel, do this, do that. While Grasshopper uses the programming, but like visual programming in the shapes, in the form of nodes and wires and connection to build this system or the program. And now we heavily use at Getinform Python language or its alternative like C# or whatever other scripting language inside Grasshopper to move beyond the limitation of built-in program commands. So parametric design is not about fancy forms or a specific form. It's building a logical system. So let's have architectural. We can say that architectural logic already is code, and AI and parametric tools just let this code to run. Let's have a quick puzzle to find this logic. Okay, the answer is here. If we find pointed ears and fluffy tail and whiskers, so it will be a cat. And if you found droopy ears, waging tail, and wet nose, so it will be a dog. So if you found round glasses, a black high collar, and no smile, so it will be, the answer is here, the architect. Most of the architects has one dress code. They are unified for it. So now architects became developers. They didn't draw anymore. They tried to develop the systems. We are not end users, and we didn't click just buttons, but we goes beyond that. We go inside the kitchen itself. So we are writing the code that generates form, and each one of us can make his own software that help in his project. Let's have a look at the structure of the AI. The AI is a big hub that includes machine learning and deep learning inside it. And then the modern architecture application is the intersection between the deep learning and other things. Like deep learning and computer vision gives us diffusion models that we often use for image generation. Natural language processing and computer vision gives the result is what we are using now for text-to-image models. Now we need to insert the computational models or computation design or the parametric modeling in the relationship with the deep learning to get some optimization or get parametric models which can understand. Like if we mix the deep learning and parametric design and the optimization, so we get AI-driven generative models. Let's see some AI workflows that could help the architects. So the most commonly used workflows that we know so far are text-to-text, text-to-image, image-to-render, sketch-to-render, image to mesh, and image to video. At Getinform, we focus on some other workflows that integrate coding directly with AI. These workflows include text-to-parametric, image-to-parametric, facade classifier or any classifier, AI for performance simulation, AI render pipelines, and AI BIM integration. The first workflow is, I call it 3Bs, which is prompt, parametric, and presentation. It's the most workflow that we use in our lab or in our design studio. So this process is a cycle of generation and evaluation. The final result is never accepted outright. It must pass through a fourth process, which is the fourth one here, the evaluation. So we start by prompting, which interprets the intention and the requirements, and then we go through the parametric, which generate and optimize the design, and at the end we go to the presentation and then start the loop again. Then I started to integrate the AI models, the LLM models inside Grasshopper to save some time to switch between the web browser and the Grasshopper. So I inserted it inside Grasshopper itself. I started with asking it some text-to-text questions. Then I turned this text to be code. For example, I wrote a concept description such as a twisted shell museum. Now AI has the capabilities to convert the natural language, which I said, for example, I said a twisted shell museum. It can get the most near or the nearest example, like geometrical form, to what I defined. The AI then analyzes the description and identifies the closest existing geometry and generate the corresponding code for it. And then I added different prompts like parameters or variables with some constraints, the minimum and maximum values, to give it more variation or get more results. Then the results, when we agree for the form, the final form, then it undergoes some AI renders, and I think it's mostly used now, the AI render in Midjourney or its alternative like LookX or Minimal. And then the resulted 3D, we use this render to test some different materials or different details to save some time to see what we are designing the concept phase with the client. And now I'm working on training an AI model to gather some specific mathematical shapes and data sets to help the model to understand the geometric translation of natural language. And this is a small example. We couldn't call it large language model. It's called small language model because it's very specific for a certain function. And we focus on converting the text to geometry through Python. Also, there is another example for this workflow. It could help us in the urban planning as well. I asked the AI here, generate a city shape or urban fabric with the specific requirements, different shapes, varying heights, and distinct properties for each building. Then the code is generated, and by refining the prompt, the model can be iterated multiple times and give many variations. So I could say traditional mixed use or historical district with different height, and it can identify the heights as well, maybe the number of floors. All of this is a small language model with a specific function. These were some further examples. I made it, I think, in the beginning of experimenting this option, that it showcased different application on the AI-aided design process in the conceptual phase. And here are some more examples as well. So next we can talk about the second workflow, which is image-to-parametric, and this is the latest one we have tested so far. It's image. We upload the image to the parametric model or to the LLM model, and then it returns back with the code that interprets this image. This workflow was very surprising for us because it helps. It shows that how the AI has a very good computer vision. Now it can interpret the images by not by the colors or the pixels, by the objects that it contains. And for example, I didn't say that this image is about Chrysler. It's just I just sent the photo to the LLM model, and then it directly converted into a parametric model, not just a code, but a parametric model. There is some, I think there is some plugins in Grasshopper now are doing this part, but image to normal Grasshopper nodes and relationship, but to convert the image to directly to a parametric model through Python. So all of this description, all this shape is described inside this node as a Python code. It was very surprising for us. So instead of generating a static 3D model, the system generates a script, and then the script contains variables inside it that allows to control and manipulate the resulting geometry, and gives also some interesting variations. There is another example here for our student Fatima. She did the same process, but with different shapes and different applications, and it was very very good to translate. Yeah, we can see that it's not exactly what it doesn't look exactly like the image, but it's very very close to what it's sent to the nearest geometrical form. The next workflow is diagram to 3D, and it deals with images that contain labels, details, and specific vocabulary. I tested it on Saudi cities code. I used the diagrams published by Development Authority Support System, which outlines specific features, vocabulary, proportions of the cities, of Saudi cities, and overall the forms required to maintain the identity of the cities itself. So I feed the diagram and I wrote all the details about each city and the identity of each one and its feature and its vocabulary, and then I got convert this image into directly 3D models. This was first the concepts are generated by Midjourney for each city. And then I tried to take each design and convert it into 3D mesh. This was a trial, so there is an option to add texture to this 3D model, but I had a problem that it doesn't complete this this step. So we can also use the textures. This helps. This part, this conversion from the image to 3D. Now it's very advanced because we can see the internal spaces as well. It's not just the external spaces. It can deduce all the 6 views or the 4 views for any image. I just started by one image and it deduced all the other views, and that was very very it was a reward for us, and because it saves like 10 times the normal rendering process to convert the concept to a 3D model. We can test on it. We can 3D print it and test it the heights and test the forms and the vocabulary mashrabiyya to see how it fits in the place. So as a start, it's a very good option. I have also experimented with the text to 3D inside Grasshopper by using the APIs of these AI models. So, for example, I asked it to generate Islamic chair or wavy lamp, and it could blend the concept very well and create the cloud, the point cloud of each mesh perfect. And it's getting advanced day by day. The next workflow and the most important one is prompt to generative design, and this is where the AI is used. The difference is that after the algorithm builds the rules and parameters, it begins to propose solutions and options based on its analysis and predictions. The AI performs an evaluation of performance, and then the outputs is a set of outcomes or results or options. We then evaluate each one and then revise the rule again and then regenerate again. So here it's prompt to parametric and generative. To differentiate between two things, like what is the difference between the automatic machine and the automatic algorithm? The automatic machine, like the washing machine, it has an algorithm, but it's fixed and pre-programmed. So like, for example, I said wash for 10 minutes, and then after washing it rinse for 5 minutes and then spin. So it's set of algorithm to perform its function. There is no adaptability, and it's only rule-based and repeat this process. But the automatic algorithm, like in the artificial intelligence self-driving car, it's a dynamic set of rules using machine learning to learn and adapt. So it could identify which is the best route to follow with its experience, and then it can customize itself without the interference of the human, and then can also learn from its errors if an outcome doesn't meet the necessary conditions which we pre-code it inside the code. So the AI results, so the AI restart the process and learn from the failure and then avoid repeating again, and that's what this technique is called reinforcement learning. Then I tried a simple example from a pine-inspired facade, taking the inspiration from nature, such as the pine structures. So I tried to generate a responsive or kinetic facade. So the goal was to achieve the maximum or minimum solar gain. It was two conditions, either to achieve maximum solar gain or minimum solar gain. Then using the sun movement, the rules defined by parameters. Here it's like a preview. It just shows me how it works when I automate the sliders. So the sliders started to get the best or the optimized solution for the condition or the goal that I set in the beginning. And here the system calculates the optimal inclination angle for the facade panels, ensuring they are responsive to the sun movement. So we can see when the sun moves, the panels moves, also opens and close, and we can then fix the design for a certain variation, and we can stop the variations at a certain point and say this is the best variation that could help in the solar gain, for example, or the solar loss. So all that happens internally in this Python node. And then we can also use this concept for a kinetic building with sensors. So the sensors could be attached to the panels itself, and in real time the sensors could react with the sun and open and close with the according to the sun intensity. The second example is the armadillo skin concept. It might help for some hot cities. So I write, modify the extrusion of these facade panels based on the sun's path to achieve maximum self-shading at midday or during the summer. So the AI runs the calculations, provide the optimized model that achieve that self-shading condition, and then classifies the facade distribution and calculate everything else, like the number of panels and also the angles of each panel, and how many units could be open and how many could be closed. This example also could be applied in the classifying the facades in an urban blocks like this one. So we can classify like the panels which is solid, which is void, and which is sunshade based on the sun path as well, or based on the sun direction. So it could classify it, which will be glass and which will be solid and which will be need to use sunshade. The last workflow is, we are still in progress, working in progress. I try to use the large language model in BIM to say by natural language, just place the window facing the north or in the south, or distribute the furniture based on the maximum daylighting, or whatever, distribute the spaces in a building or apartments in a building as well. So these efforts focus on the distribution of things according to natural language, our natural language, it passed through many steps to get the geometry done in Revit, inside Revit. I used here Dynamo to achieve this function. So finally, this was a rapid overview of how architects can use AI in their daily work and how we use it at Getinform. So by training the machine to assist us in our core process, we can save significant time and achieve the highest level of efficiency in our designs. Thank you so much.